Okay, this video is going to go through an explanation at least on some of these answers. Um, so if you, hopefully you already checked to see which ones you missed so you can go through the video and find only the problems that you missed so you can get the explanation. So as we look at this, let me see, this is a Boolean expression, probably nothing to explain here except for you're always going to have a relational operator here, so it's either be less than or greater than, equals, or things like that. This is just an assignment operator. It's not involved in a Boolean expression here. It's an assignment operator, just like we've been doing all along since chapter 2. This is an if statement. An if statement has an if and a Boolean expression, or a condition, or a test, as the author would put it. And so an else if statement, same thing. It's else if, and it's got a Boolean expression, so we just call it an else if statement. Line 3 and 4. Okay, so in here, this is, so you have your statement, your if statement, and so if this is true, then the compiler is going to execute the clause. So this is called a clause. It's an if clause because it's below an if statement. Makes sense? So the book might call it a branch, an if branch. This is an else if statement, and so the clause is associated with an else if statement. All right, so it's called an else if clause. And this clause here is associated with an else statement, so it's just called an else clause or else branch. These are just vocabulary words that help us to communicate. Number 2 is, okay, so these are the 6 relational operators. Relational operators used to compare numeric data or numbers. And we distinguish that because when you compare strings, you got to use the equals and the equals ignore case. So those are used to compare strings. What characteristics do, okay, so if you'll notice up here that an if statement has a Boolean expression, an else if statement has a Boolean expression, but an else statement does not. It's just, this is just means that anything else, any remaining choice by the input or input by the user will cause this to be run. So that means all the previous Boolean expressions must have been false. So anyway, there's no Boolean expression with the else statement. Then we move on. Okay, which lines of code will be executed? All right, now the point is this, is that we don't know the value of num1 or num2, so we don't know, or num3, so we don't know if num1 is greater than num2. So how would you explain which of these lines? Well, the general rule here, and this is the whole idea behind our if-else structures, is that the line of code associated with the first Boolean expression that is true is going to be the one it does first. So let's say that this is false. Then remember, if that's false, it ignores this one. Now let's say this is true. Let's say this Boolean expression is true. Then it's going to execute line 7 and ignore the rest. So the first Boolean expression is true. Its respective clause is the one that's going to be executed. So let's say that this is false. It ignores. Let's say this is false, and this is ignored. And let's say this one's true. Let's say this one's true. Then it's going to execute line 11 in this case, and then everything else would be ignored. So the only way we can describe which of these 4 lines will be executed is going to be the line of code associated with the first Boolean expression. That's true. Now, I probably should add on here that or line 15 if all the Boolean expressions are false. So that's what I think I need to add to this. So it's the it's the line of code associated with the first Boolean expression that's true, as I demonstrated here, or it's line 15 if all of these are false. All right. Now, what decision is the compiler trying to make by evaluating the Boolean expression in line 5? So, if it's evaluating this one, it's trying to decide, or it's not deciding, it's evaluating whether this is true or false. The decision it's going to make is, if this is true, it's going to go ahead and execute this. But if it's false, it's going to ignore it. So it's making the decision to either execute or ignore line 7. That is the idea. All right. Okay, number 7. If an if-else structure has 6 alternatives, how many of each of the following would be included? Well, the first statement has to be an if. And it's only one if statement in the if-else structure. It's got to end with the else statement if you're going to use an else statement. Everything else in between is going to be else ifs. So you only can have one if statement, and it's got to be at the beginning. You can only have one else statement, and it's got to be at the end. That takes up 2 alternatives. That means you need 1, 2, 3, 4 else ifs in order to accommodate all 6 alternatives. And so the example up here is that there are 1, 2, 3, 4 alternatives. So we have one here, one if, one else, and so we need 2 more else ifs, 2 else ifs to accommodate all 4 alternatives. In what order would they occur? And this, like we just showed here, starts at if, ends with else, everything else is else if in between. When are else clauses executed? When all Boolean expressions are false. And we've already demonstrated that up here. If this is false, then this is ignored. Then it goes in here. If that's false, this is ignored, and then it goes to here and evaluates this. If this is false, it's ignored. I'm sorry, it's ignored. And then so therefore, it executes this, the else clause. All right, number 9. Write a Boolean expression for each of the following. Let's see if we can. Let's see. Evaluates if num1 is at least the size of num2. So the way you could look at this is you pick a number, and this is what I used to teach in algebra, is that pick a number, at least the size. Let's say num2 is 7. Okay, if num1 is going to be at least 7, you ask yourself, well, you go to the left. Is 6 at least 7? Nope. Is 7, use a boundary, is 7 at least 7? Yes. Is 8 at least 7? Yeah, it is. So we're talking about a number that is either equal to or greater than 7. So that's what we have, is num1 greater than or equal to num2. Now what you do is then let you pick that number, you put that number, and you ask yourself to see if this works. And then so you could go, is 6 greater than or equal to 7? No. Is 7 greater than or equal to? Yes, it's equal to. Is 8 greater than or equal to? Yes, it is greater than 7. All right, B. Evaluates if num1 is the size of num2 or smaller. So let's pick another num2. Let's say num2 is 7. Evaluates if num2 is the size. Okay, so is 6 the size of num2 or smaller? Well, it is. It's smaller, so that's good. How about 7? You take the border or the boundary line. Is num1 or is 7 the size of 7? Yes, or smaller. It is. Now 8. Is 8 the size of num2 or smaller? No. So that means it's got to be 7 or less. So that's why we say less than or equal to. It's either less than or it's equal to. Okay, evaluates if num1 is the same as the sum. All right, so the same, we have to have an equals equals, not just an equals. So evaluates if num1 is the same as the sum, which is just adding them together. Hopefully that makes sense. Evaluates if num1 divided by num2 has a remainder of 0. So remainder is the modulus operator. And so you're checking to see if and this returns the remainder of num1 divided by num2. So it does the division and then pulls out the remainder. So the question is the remainder, and this, remember, this returns the remainder. So if we did, let's say 7 divided by 6, well, the remainder is 1. 6 goes into 7 once, and it has a remainder of 1. So is 1 equal to 0? And of course, that would make it false. All right, so let's go on to E. Evaluates if the sum of num1 and 2 is larger than the difference of num3 and num4. So here's the sum of num1 and num2. Is it larger than the difference of num3 and num4? So whenever it talks about the difference, then you just go in the order in which the numbers are mentioned. So num3 minus num4. Uh-oh. I have 2 E's. Okay. Such is life. So let's go with the second E. If num1 divided by num2 does not have a remainder of 0. Evaluates if num1 divided by num2 does not have a remainder of 0. Now remember, the modulus operator is the percent symbol. So this returns the remainder of the division problem, num1 divided by num2. So this will return that. And it's saying, is the division, or is the remainder 0 or not? So if it says, does it not? So remember, this is not equal to 0. All right, so if the remainder of this was, let's say that it was 4 remainder 2. So it would be asking, is 2 not equal to 0? And that would be true statement. All right, evaluates if num1 is divisible by num2. In order for a number, let's just take an example. If you go, is 10 divisible by 2? And you would say, yes, it does. Is 10 divisible by 3? And you would say, no, it isn't. Well, what makes this the case? Well, 10 is divisible by 2 because 2 goes in it with 5 times with the remainder of 0. So anytime there's a 0 remainder, we know that these numbers are divisible. And so, but this one is 3 remainder 1. So it has a remainder of 1. So what we're really asking, in order for a number to be divisible by another number, its remainder has to be 0. Anything else, it will not go in evenly. So we're asking, is the remainder, that's this, equal to 0? And in this case, if num1 was 10 and num2 was 3, it would return a 1. So it's asking, is 1 equal to 0, which that would be false. Now, if num2 was 2 instead, the remainder is 0, so it's asking, is 0 equal to 0, and which would be true in that case. Evaluates if num1 is an even number. Well, what makes a number an even number? An even number is any number that's divisible by 2. How do we decide if it's divisible by 2? We did it in F. All right? So if the remainder of num1 divided by 2 is 0, it's an even number. All right? So that we're doing the same idea here. We're asking if num1 is divisible by 2. Evaluates if the num1 is odd number. Well, if it's not divisible by 2, if the remainder, let's say if you take a number like 13 and you divide it by 2, it's going to be 6 remainder 1. Well, so num1 modulus 2 is going to be 1. Is 1 not equal to 0? That's true. That means this must be an odd number. And it is. So, if you have a number like 14 divided by 2, that's going to equal 7 remainder 0. 7 remainder 0. So, the modulus of, let's say num1 is 14, the remainder is 0. So is 0 not equal to 0? No, that's false, because 0 is equal to 0. So that means it must be an even number. It's not an odd number. Okay, evaluates if num1 is no more than num2. Okay, let's take this num2 again and make it 7. So is num1, so you take the left side. Okay, is 6 no more than 7? Well, that's true. It is no more. It's not more than 7. Okay, is 7 no more than 2? Well, that's not more either. 8. Is 8 no more than 7? No, that's not true. So therefore, it's going to be a number that's less than or equal to 7. So that's why we have that there. Okay, we're going to stop this video and I'll do one more video for the remaining part of this exercise.